March 17th, 1943. The North Atlantic, 400 miles southwest of Iceland. Captain James Morrison stood on the bridge of SS William Clark, watching ice form on the forward gun mount. The convoy, designated HX-229, had been at sea for 6 days, pushing eastward through seas that rolled grey and hostile under overcast skies. 41 merchant ships arranged in 9 columns, each vessel separated by 600 yards, the entire formation stretching 3 miles across the ocean. Morrison had commanded merchant vessels for 19 years. He'd sailed these waters in peacetime, when the greatest dangers were weather and mechanical failure. Now, beneath those grey waves, German submarines hunted with methodical precision. The William Clark carried 10,000 tons of food, ammunition, and medical supplies desperately needed in Britain. Morrison knew the statistics. Since September 1939, German U-boats had sent over 2,000 Allied merchant ships to the bottom. That represented roughly 12 million tons of shipping, more cargo capacity than existed in the entire British merchant fleet when the war began. The mathematics were brutally simple. If German submarines continued sinking ships faster than Allied yards could build replacements, Britain would starve. Her armies would run out of ammunition. Her factories would close for lack of raw materials. Germany would win the war without ever invading the British Isles, simply by severing the maritime arteries that kept the nation alive. Admiral Karl Dönitz, commander of Germany's U-boat force, had calculated exactly how many merchant ships his submarines needed to sink monthly to achieve this strangulation. The number was 600,000 tons. Sink that much every month, and Allied shipping capacity would collapse within 18 months. Through 1942, Dönitz had exceeded his target in 8 months out of 12. In November 1942, alone, U-boats sank 729,000 tons of Allied shipping. The German naval staff prepared operational plans for the period after Britain's inevitable surrender. They discussed which ports would serve as forward bases for operations against the United States. They debated whether convoy routes to South America would need protection from American submarines. The assumption underlying every discussion was that the Battle of the Atlantic was nearly won. What German intelligence analysts failed to comprehend was taking shape 7,000 miles away in shipyards that hadn't existed 3 years earlier, built by a nation with virtually no merchant shipbuilding tradition. The transformation had begun with a single, desperate decision made in the spring of 1940. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. May 20th, 1940. London. Winston Churchill met with representatives from the British Purchasing Commission to discuss a crisis that threatened to undermine everything. German forces had just conquered France in 6 weeks. The British Army had evacuated from Dunkirk, leaving virtually all its heavy equipment behind. Britain stood alone against Nazi Germany with an army that had rifles but few tanks, artillery pieces, or trucks. The immediate problem wasn't just military equipment. Britain imported 60% of her food supply. Her steel mills relied on imported iron ore. Her factories needed imported machine tools, chemicals, and raw materials. All of it crossed the Atlantic in merchant ships that German U-boats were sinking at an accelerating rate. Arthur Purvis, head of the British Purchasing Commission, presented Churchill with projections that were frankly catastrophic. Britain's merchant fleet comprised approximately 3,000 ships, totaling roughly 21 million tons of capacity. German submarines and surface raiders were currently sinking ships at a rate that would eliminate roughly 10% of that capacity annually. Meanwhile, British shipyards, using traditional construction methods, could build perhaps 60 new cargo vessels per year. The mathematics showed Britain losing 2 million tons of shipping capacity yearly, while replacing barely 600,000 tons. Within 3 years, Britain's merchant fleet would be too small to maintain minimal supply levels. Starvation would become reality before 1944. Churchill grasped the implications immediately. Britain could have the finest navy in the world, the most determined army, the most capable air force, but none of it mattered if merchant ships couldn't deliver food and ammunition. He asked Purvis a question that would alter the course of the war. How many merchant ships can America build? And how quickly? Purvis had already investigated American shipbuilding capacity. His answer was disappointing. The United States had approximately 40 shipyards capable of building large merchant vessels. These yards used traditional construction methods unchanged since the 1800s. Building a cargo ship required laying a keel, then constructing the vessel plate by plate, frame by frame, from bottom to deck over 6 to 8 months. American yards might manage to build 120 to 150 merchant ships annually if they operated at full capacity. That wasn't nearly enough. Even combining British and American production, Allied shipyards would replace perhaps 210 ships yearly, while losing 300 or more to enemy action. The deficit was unsustainable. Britain needed not 150 ships annually, but 500, perhaps 1,000. Churchill directed Purvis to approach the United States Maritime Commission with a proposal that seemed impossible. Britain would provide financing for American shipyards to expand dramatically and adopt new construction methods that could produce merchant vessels not in months, but in weeks. The traditional maritime establishment would consider this technically absurd. Ships were complex machines requiring skilled craftsmen and careful construction. You couldn't build them like automobiles. Admiral Emory Land, chairman of the United States Maritime Commission, received Purvis's proposal in June 1940, with professional skepticism mixed with recognition of desperate necessity. Land was a career naval officer and engineer. He understood that merchant ship construction had changed little in a century because the methods worked. Riveted steel hulls built by skilled workers produced seaworthy vessels. But Land also understood arithmetic. He examined British shipping losses and replacement rates. The numbers were undeniable. Unless something changed dramatically, Britain would lose the Battle of the Atlantic through simple attrition. The question wasn't whether radical innovation was theoretically preferable to traditional methods. The question was whether adequate ships built quickly were better than perfect ships built slowly when the enemy was sinking vessels faster than conventional yards could replace them. Land authorized the Maritime Commission to issue contracts for 60 cargo ships to be delivered by December 1941, with construction methods and timelines to be determined by the shipbuilders. The contract specifications included one unusual requirement. Builders were encouraged to propose unconventional construction techniques if such methods could demonstrably reduce construction time. 3 established shipyards submitted proposals using conventional riveted construction, with estimated delivery times of 7 to 9 months per vessel. Then a proposal arrived from a man who had never built a ship in his life. Henry John Kaiser was 58 years old in 1940. He had made his fortune building dams, highways, and bridges across the American West. His company had constructed the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam. He had moved more earth and poured more concrete than perhaps any contractor in American history. He had never constructed anything that floated. Kaiser's proposal to the Maritime Commission was audacious to the point of seeming delusional. He promised to build 30 cargo ships in 24 months, delivering the first vessel within 12 months of contract signing. More remarkably, he proposed using welded construction instead of riveting and assembly line techniques borrowed from automobile manufacturing instead of traditional shipyard methods. Established shipbuilders read Kaiser's proposal with contempt. Todd Shipyards, one of America's oldest maritime construction firms, submitted detailed technical criticism, explaining why Kaiser's approaches would fail. Ships were not automobiles. Maritime construction required skills developed over generations. Was unproven for large hull structures. Assembly line techniques designed for small manufactured goods couldn't scale to vessels weighing 10,000 tons. Admiral Land read both the established yard's criticisms and Kaiser's proposal. He made a decision that reflected desperation more than confidence. He approved Kaiser's contract on condition that Todd Shipyards provide technical oversight and access to proven ship designs. If Kaiser failed, at least the nation wouldn't have wasted money on complete fantasy. Kaiser signed his first shipbuilding contract on December 27, 1940, promising delivery of 30 cargo vessels by December 1942. He immediately travelled to England to examine the ship designs Britain was providing. The British had developed standardised cargo vessel plans based on a 1939 tramp steamer design. The ships were intentionally simple: single-deck, coal-fired steam engines, minimal accommodation. These weren't elegant vessels. They were floating cargo boxes designed to be built quickly and cheaply. The British called them Empire ships. The Americans would call them Liberty ships. The name came from President Franklin Roosevelt, who declared in a September 1941 speech that America would build a fleet of Liberty ships to ensure democratic nations could defend themselves. The propaganda value was excellent. The technical reality was that these would be the simplest, most basic cargo vessels that could possibly be considered seaworthy. Each Liberty ship would be 441 feet long with a beam of 57 feet. Fully loaded, they would displace 14,245 tons. The cargo holds could carry 10,800 tons of freight. That was equivalent to 300 rail cars worth of supplies. A single Liberty ship could transport 500 jeeps, or 2,500 tons of ammunition, or enough food to feed an army division for 6 months. The ships were deliberately designed for mass production rather than longevity. The engines were old-fashioned triple-expansion steam power plants, a technology dating to the 1880s. Modern diesel engines were more efficient, but triple-expansion engines could be manufactured by any factory capable of building large metal components. No specialized knowledge was required. The engines were slow, producing just 2,500 horsepower, giving the ships a maximum speed of 11 knots. Modern cargo vessels could achieve 15 to 18 knots, but speed required complex engines and more sophisticated hull design. Liberty ships traded speed for simplicity. The hull design was equally basic: straight sides, flat bottom, minimal curves. This allowed steel plates to be cut in rectangular sections and welded together with minimal complex forming. Traditional cargo ships had compound curves that required skilled shipwrights to shape each plate individually. Liberty ships eliminated that craftsmanship requirement entirely. Kaiser returned to California in January 1941 and began building a shipyard on empty mudflats in Richmond, across the bay from San Francisco. What he constructed horrified traditional maritime engineers who visited the site. Instead of the massive stone and steel infrastructure that characterized established shipyards, Kaiser built what looked like an enormous factory. The facility featured 7 parallel building ways, each one 450 feet long. That was barely longer than a Liberty ship, meaning vessels would be built almost entirely on the ways rather than in dry docks. Massive gantry cranes, capable of lifting 150 tons, ran on rails along each building way. Huge open areas surrounded the ways, designated for prefabrication of ship sections. Traditional shipyards built ships sequentially. The keel was laid, then frames erected, then hull plates attached one by one, then decks installed, then superstructure added, with each phase requiring completion before the next could begin. Kaiser's facility was designed for parallel construction. Different sections of a ship would be built simultaneously in the prefabrication areas, then lifted onto the building ways and welded together. The concept was borrowed directly from automobile manufacturing. In a car factory, engines weren't built inside the vehicle. They were assembled separately, then installed in a few hours. Kaiser proposed applying the same logic to ships: build the bow section in one area, the stern section in another area, the engine room in a third area, all simultaneously. When complete, use cranes to position all sections on the building way and weld them together. Traditional shipbuilders declared this impossible. Ships weren't cars. The stresses on a ship hull required integrated construction to ensure structural integrity. You couldn't just bolt together prefabricated sections and expect the result to survive Atlantic storms. The welding itself was suspect. Riveting had been proven reliable over a century. Rivets allowed slight movement between plates, providing flexibility, Welded joints were rigid, transferring stresses that might crack the hull. The British Admiralty had prohibited welding on warship hulls for exactly this reason. Kaiser ignored the criticism and began hiring workers. He needed thousands of employees, but Richmond had a population of just 23,000. Kaiser advertised in newspapers across California, Oregon, and Washington. The advertisements promised wages 20% above standard industrial rates and guaranteed training for anyone willing to work. The workers who arrived were housewives, farmers, shop clerks, laborers, anyone needing employment. Fewer than 5% had any shipbuilding experience. Most had never seen a welder. Kaiser didn't care. He established training schools that taught specific tasks in 2 to 3 weeks. Workers didn't need to understand shipbuilding. They needed to know how to weld vertical seams on bulkheads, or cut steel plate to specifications, or operate a specific crane, or install piping in engine rooms. By August 1941, Richmond employed over 10,000 workers. Traditional shipyards operated with perhaps 2,000 to 3,000 employees because skilled maritime workers were scarce. Kaiser's approach didn't require skilled maritime workers. It required people capable of learning specific, repetitive tasks and executing them consistently. The first Liberty ship keel was laid at Richmond on April 14, 1941. Ship number 1, which would be named SS Patrick Henry, began as sections of steel plate being welded together in the prefabrication areas. Bow frames took shape in one corner of the facility. Stern sections grew in another area. The engine, manufactured by Joshua Hendy Iron Works in Sunnyvale, was mounted on a steel foundation and tested before leaving the factory. Traditional shipbuilders watched with fascination and skepticism. The Richmond yard looked chaotic. Steel sections moved constantly on rail cars. Cranes swung loads overhead continuously. Workers swarmed over prefabricated sections, welding, cutting, grinding, painting. It resembled a factory floor more than a shipyard. What observers couldn't see was the systematic organization beneath the apparent chaos. Every section had a construction schedule. Every crane movement was planned. Every worker knew exactly which task to perform and where materials would be positioned. Kaiser had brought construction management techniques developed building dams to shipbuilding, critical path scheduling, just-in-time material delivery, parallel task execution, all were standard practice in dam construction. Maritime industry had never seen such approaches. The Patrick Henry was launched on September 27, 1941, 165 days after her keel was laid. That was faster than any American shipyard had built a vessel of comparable size in decades. It was still far too slow to meet Britain's desperate needs. Admiral Land visited Richmond in October 1941. He congratulated Kaiser on completing the first ship, but noted that 165 days per vessel meant Richmond could produce perhaps 12 to 15 ships annually. Britain needed hundreds of ships, not dozens. Kaiser promised that construction time would drop dramatically as workers gained experience and prefabrication techniques improved. Land remained skeptical. In November 1941, he wrote in a confidential memo to President Roosevelt that Kaiser's program showed promise but couldn't possibly achieve the production levels Britain required. The memo noted that even if construction time fell to 90 days per ship, which seemed optimistic, American yards might build 250 Liberty ships annually. That would barely match German sinking rates, not exceed them. Then events overtook everyone's calculations. December 7, 1941, Japanese carrier aircraft attacked Pearl Harbor. The United States entered World War II not as a neutral supplier, but as a combatant. America's shipping requirements exploded overnight. The military needed transport for troops, tanks, aircraft, ammunition, fuel, and supplies. The civilian economy needed continued imports of raw materials. Britain's desperate need became America's desperate need. President Roosevelt addressed Congress on January 6, 1942, outlining production goals that stunned both industry and military planners. He declared that America would build 8 million tons of merchant shipping in 1942 and 10 million tons in 1943. Those numbers represented roughly 1,600 merchant ships in 1942 and 2,000 ships in 1943. Traditional maritime analysts declared Roosevelt's goals impossible. America's existing shipyards, operating at maximum capacity, might build 400 ships annually. Roosevelt was demanding 4 times that production from facilities that didn't yet exist, using workers who hadn't been trained, constructing vessels in time frames that violated every principle of maritime construction. Kaiser heard Roosevelt's speech and recognized opportunity. He immediately contacted the Maritime Commission, proposing to expand his Richmond facility and build additional shipyards in Portland, Oregon, and Vancouver, Washington. He promised he could build 150 Liberty ships annually across his 3 yards once they reached full production. The Maritime Commission, desperate for any solution, approved Kaiser's expansion. By March 1942, construction had begun on massive new shipbuilding facilities. The Portland yard would have 10 building ways. The Vancouver yard would have 6. Combined with Richmond's 7 ways, Kaiser's facilities would be capable of constructing 23 Liberty ships simultaneously. The statistics emerging from Richmond in early 1942 demonstrated that Kaiser's promises weren't empty boasts. Ship number 2 required 169 days to build. Ship number 5 took 128 days. Ship number 10 took 97 days. By April 1942, Richmond was completing Liberty ships in 70 to 80 days on average. The improvement came from systematic analysis of bottlenecks and continuous refinement of prefabrication techniques. Kaiser employed industrial engineers who observed construction processes and identified delays. If cutting steel plate was slow, Kaiser bought more cutting torches and trained more workers. If crane movements created delays, Kaiser added more cranes and revised schedules. Every problem received immediate attention and resources. Traditional shipyards operated on the assumption that skilled workers would identify and solve problems through their expertise. Kaiser's yards operated on the assumption that systematic observation and measurement would reveal problems that could be solved through better organization and more resources. When worker fatigue reduced productivity on long shifts, Kaiser didn't demand longer hours. He hired more workers and shortened shifts. The prefabrication strategy showed its power by April 1942. Instead of building 1 ship at a time from keel to deck, Richmond was simultaneously constructing components for 6 different ships. While one crew assembled a bow section for Ship 23, another crew built stern sections for Ship 24, while a third crew fabricated deck houses for Ship 25. When all sections were ready, massive cranes lifted them onto the building ways where welding crews joined them together. Albert Woodring, production supervisor at Richmond Yard No. 2, explained the efficiency in an April 1942 report to the Maritime Commission. Traditional construction builds ships serially. Our approach builds ships in parallel. A conventional yard has 50 workers attempting to install an engine over 3 weeks in a cramped engine room. We assign 200 workers to assemble the engine in an open workshop over 5 days, then use cranes to lower the completed engine into the prepared engine room in 8 hours. Tasks that required weeks now take days. By June 1942, Richmond was completing Liberty ships in an average of 56 days. Portland and Vancouver yards were coming online, adding capacity. Kaiser's 7 yards, counting facilities built later in California and Oregon, were approaching the capability to launch a Liberty ship daily when all reached full production. German naval intelligence monitored American shipbuilding with growing concern. Reports from agents in the United States described massive construction programs underway. Admiral Dönitz received intelligence summaries in mid-1942 indicating that American yards might build 800 merchant ships in the next 12 months. He dismissed these reports as exaggerated. No nation could construct 800 ships annually. The United States didn't have enough skilled shipyard workers to crew that many facilities. The reports must reflect planned capacity rather than actual achievable production. Dönitz's analysis was logical based on traditional shipbuilding assumptions. Germany's own shipyards, among the finest in Europe, built approximately 40 U-boats annually at full capacity. Each U-boat required skilled workers and 9 to 12 months construction time. Scaling that to merchant ships suggested that building 800 vessels would require industrial capacity exceeding Germany's entire manufacturing base. What German intelligence failed to understand was that Kaiser had eliminated the skilled worker requirement. His yards didn't employ maritime craftsmen. They employed factory workers executing specific tasks. The distinction was crucial. You couldn't train skilled shipwrights in weeks. You could train spot welders, crane operators, and pipe fitters in weeks. Kaiser's approach didn't require traditional shipyard workers. It required manufacturing labor, which America possessed in abundance. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The mathematics of shipping losses versus production began shifting in mid-1942. In June, U-boats sank 623,000 tons of Allied shipping. In the same month, American shipyards delivered 400,000 tons of new merchant vessels, still a deficit, but the gap was narrowing. In July, sinkings totaled 538,000 tons, while deliveries reached 510,000 tons. The crossover was approaching. August 1942 marked the turning point. German submarines sank 491,000 tons of Allied shipping. American yards delivered 560,000 tons of new ships. For the first time since the war began, Allied ship production exceeded losses in a single month. The deficit began reversing. Admiral Dönitz recognized the implications immediately. He submitted urgent requests to German Naval Command for increased U-boat production. His analysis showed that if American shipbuilding continued at current rates, Germany would need to sink 750,000 tons monthly just to prevent the Allies from accumulating shipping capacity. That required more submarines than Germany currently operated in the Atlantic. German Naval Command responded that U-boat production was already maximized. The submarine service was receiving priority for steel allocation, skilled workers, and manufacturing capacity. Producing more U-boats meant building fewer surface warships, which the traditional German Navy leadership opposed. Dönitz argued that surface warships were irrelevant if Germany lost the Atlantic. British convoys escorted by destroyers couldn't be attacked by battleships without risking catastrophic losses. Submarines were the only effective commerce raiders. Everything else was wasted resources. The internal German debate over U-boat production continued through fall 1942, while American shipyards accelerated. By October, Kaiser's yards alone were completing 4 Liberty ships weekly. Nationally, American production reached 600,000 tons monthly. The accumulated shipping tonnage in Allied service began growing for the first time since 1940. November 1942 brought the record-setting construction of SS Robert E. Peary, built in 4 days and 15 hours from keel laying to launch. The achievement was part demonstration, part competition between Kaiser's yards, and entirely symbolic. It proved that Liberty ship construction had been completely systematized. Every component could be prefabricated. Every assembly step could be optimized. Time from keel to launch was now limited only by how much labor Kaiser chose to assign. The Peary's construction wasn't representative of typical Liberty ship builds, but it demonstrated the potential of Kaiser's methods. If economic considerations were ignored and maximum labor applied, a Liberty ship could be constructed in less than a week. Under normal production schedules with resources distributed across multiple ships simultaneously, Kaiser's yards were completing vessels in 35 to 45 days consistently. British observers visited Richmond in December 1942 and submitted reports to the Admiralty that reflected shock and admiration. Commander Ian Fleming, who would later write the James Bond novels, was serving with British naval intelligence at the time. His report on American shipbuilding, declassified in the 1980s, captured British reactions. The Americans are building merchant ships at a rate that would have been dismissed as propaganda if we were not witnessing it directly. Richmond shipyard employs 90,000 workers, most of whom learned their trades within the past 12 months. They are completing 400-foot cargo vessels weekly. The ships are crude by British standards, lacking the refined finish of traditional maritime construction. But they are seaworthy, and there are dozens of them appearing constantly. By January 1943, American shipyards were delivering 90 Liberty ships monthly. That represented 1 million tons of new shipping capacity, enough to replace all U-boat sinkings and add surplus capacity. The accumulated American merchant fleet was growing even while ships were being sunk. The strategic implications became clear to German planners in early 1943. A naval staff analysis completed in February calculated that U-boats would need to sink 1 million tons monthly to prevent Allied shipping capacity from growing. Current sinking rates averaged 600,000 tons monthly. The deficit meant Allied shipping would expand by roughly 4 million tons annually, even accounting for losses. Admiral Dönitz was promoted to Commander-in-Chief of the German Navy in January 1943, replacing Grand Admiral Erich Raeder, who had clashed with Adolf Hitler over strategy. Dönitz's promotion reflected recognition that submarine warfare was Germany's only effective naval strategy. His first action was requesting permission to transfer steel allocated for battleship construction to U-boat production. Hitler approved, but the changes couldn't be implemented quickly enough. By March 1943, when Captain Morrison's convoy, HX-229, crossed the Atlantic, the mathematical inevitability was becoming clear even if German commanders weren't ready to acknowledge it. Morrison watched the convoy's progress with the anxiety every merchant captain felt in the North Atlantic. HX-229 included 41 ships, of which 23 were Liberty ships. These vessels, less than a year old, carried food, ammunition, aircraft, tanks, and supplies. The convoy had departed New York on March 10th and was now approaching the Mid-Atlantic Air Gap, the region beyond range of land-based patrol aircraft, where U-boats could attack with minimal risk. German naval intelligence had identified HX-229 as a valuable target. Convoy routing information obtained through intercepted radio traffic indicated the convoy would pass through grid square AK-53 on March 17th. Admiral Dönitz ordered a patrol line of 18 U-boats to position themselves along the convoy's projected route. The attack began at 10:42 p.m. on March 17th. U-boats approaching on the surface fired torpedoes at merchant ships silhouetted against the moonlight. The first Liberty ship hit was SS William Pierce, struck by 2 torpedoes fired by U-606. The ship broke in half and sank within 8 minutes. 36 crew and gunners went into the water. Only 12 survived to be rescued by escorts. Morrison on the William Clark watched explosions ripple through the convoy as U-boats attacked from multiple directions. Standard procedure was for merchant ships to maintain course and speed while escorts counterattacked. Running from danger only opened gaps in the convoy that gave U-boats easier targets. Morrison kept his ship in formation while torpedoes passed close enough that he could see their phosphorescent wakes in the dark water. The attack continued through the night and into March 18th. U-boats sank 12 merchant ships from HX-229, including 4 Liberty ships. The convoy's escorts sank 2 U-boats and damaged 3 others, but the exchange rate favoured Germany. 12 merchant ships totaling 72,000 tons sunk in exchange for 2 submarines. Admiral Dönitz reviewed the action reports with satisfaction. His U-boats were still achieving favourable kill ratios. But he also noted that HX-229 had departed New York with 41 ships. 7 months earlier, an Atlantic convoy typically comprised 25 to 30 vessels. The convoys were growing larger because more ships were available. Even after losing 12 vessels, HX-229 delivered 29 merchant ships to Britain with their cargoes intact. The statistics Dönitz received in late March 1943 revealed the strategic problem clearly. In March, U-boats sank 108 Allied merchant ships, totaling 627,000 tons. In the same month, Allied shipyards, primarily American facilities, delivered 142 merchant ships, totaling 900,000 tons. The Allies gained net shipping capacity of 273,000 tons, despite U-boat operations. German naval staff prepared projections for April through December 1943. If American production continued at current rates, the Allies would add 6 million tons of shipping capacity by year's end, even accounting for continued losses. That surplus would allow Britain to increase imports, support expanded military operations in the Mediterranean and Pacific, and build reserves for the anticipated invasion of France. The most disturbing aspect was the trend line. American shipbuilding was still accelerating. Kaiser's Portland and Vancouver yards had reached full production capacity by April 1943. Other American shipyards, having studied Kaiser's methods, were adopting prefabrication and welding. Average construction time across all American yards, building Liberty ships, had fallen to 42 days. Some efficient yards were completing ships in 32 to 35 days consistently. President Roosevelt's January 1942 production goals, dismissed as impossible by maritime experts, were being exceeded. The target had been 8 million tons of shipping in 1942. Actual production reached 8.3 million tons. The 1943 target of 10 million tons would be surpassed, with actual production reaching 12 million tons. The 18 American shipyards building Liberty ships were collectively launching 3 ships daily by mid-1943. Each ship could carry 10,800 tons of cargo. That represented 32,000 tons of cargo capacity added daily, or nearly 1 million tons monthly. Germany's entire U-boat force at maximum effort was sinking roughly 600,000 tons monthly. The arithmetic was inexorable. America was building cargo capacity 50% faster than Germany could sink it. The deficit meant Allied shipping would expand, continuously regardless of U-boat successes. Every convoy that crossed the Atlantic, even if U-boats sank several ships, delivered more cargo than the previous month because more ships were sailing. British food imports, which had fallen to dangerous lows in late 1941, began recovering in mid-1943. Grain reserves that had been measured in weeks grew to months of supply. Fresh fruit appeared in markets. Meat rations increased slightly. The British population noticed that ships were arriving faster than they were being sunk. The operational reality facing U-boat commanders changed fundamentally through spring and summer 1943. Captain Lieutenant Herbert Werner commanded U-230, operating in the North Atlantic from April through June. His war diary, published after the war, captured the frustration of hunting convoys that grew larger and better defended while his submarine faced increasing danger. Werner recorded on April 23, 1943, that his patrol had located convoy ONS-5, westbound from Britain with 43 merchant ships. Standard procedure was to radio the convoy's position to U-boat headquarters, allowing other submarines to converge for a coordinated attack. Werner surfaced to transmit and was immediately detected by radar-equipped escorts. He crash-dived to avoid depth charges, losing contact with the convoy. The experience was repeated across the U-boat force. New Allied radar systems, particularly the centimetric radar that operated on 10-centimeter wavelengths, detected surfaced submarines at ranges exceeding 6 miles. U-boats could no longer shadow convoys on the surface, radioing position updates while staying beyond visual range. Any surface operation risked immediate counterattack. Werner's patrol sank 1 merchant ship, a Norwegian freighter of 4,000 tons, over 6 weeks of operation. He expended 11 torpedoes, survived 37 depth charge attacks, and returned to base with his submarine damaged and crew exhausted. The exchange rate, 1 old freighter for 6 weeks of patrol and extensive damage, represented a strategic disaster for Germany. Admiral Dönitz received patrol reports from across the U-boat force, showing similar results. In May 1943, 41 U-boats were lost, the highest monthly loss rate of the war. Submarines were being sunk faster than German yards could build replacements. Meanwhile, Even with those losses, U-boats had sunk only 50 Allied merchant ships totaling 305,000 tons in May. In the same month, American yards delivered 132 merchant ships totaling 850,000 tons. The ratio was devastating. Germany was losing submarines at unsustainable rates, while achieving sinking totals that represented barely one-third of American replacement production. The Battle of the Atlantic had shifted from a German offensive threatening Allied supply lines to a German defensive struggle for survival. Dönitz ordered U-boats withdrawn from the North Atlantic convoy routes on May 24, 1943. The official reason given to commanders was that submarines needed retrofitting with improved anti-aircraft weapons to counter Allied patrol aircraft. The actual reason, which Dönitz acknowledged in private correspondence, was that continuing operations under current conditions would result in the complete destruction of the U-boat force within months. The withdrawal represented Germany's acknowledgement that the Atlantic campaign had failed. Britain would not be starved. Allied shipping capacity would continue growing. The invasion of Europe could proceed because supplies would flow across the Atlantic without interruption. Everything Dönitz had promised, everything the U-boat force had sacrificed to achieve, had been negated by American industrial production. The German naval staff prepared an analysis in June 1943, examining why the Atlantic campaign had failed. The report, captured after the war and now held in the National Archives, provided remarkable clarity about German strategic miscalculation. The analysis noted that German planning had assumed Allied shipbuilding capacity was fixed. Intelligence estimates suggested Britain could build 60 merchant ships annually and the United States perhaps 120 ships using traditional construction methods. At those production rates, sinking 600,000 tons monthly would exhaust Allied capacity within 2 years. The fundamental error was failing to recognize that American industry operated under different constraints than European industry. Germany's shipyards were limited by skilled worker availability. Training a shipwright required 4 years. Expanding production required training more workers, a slow process. American industry, particularly Kaiser's yards, had eliminated the skilled worker requirement. Training a spot welder took 2 weeks. Expanding production required only hiring more workers and building more facilities. The report concluded that Germany had been fighting American organizational capacity rather than American industrial capacity. The steel, the workers, the resources existed in abundance. What America lacked initially was the organization to channel those resources into ship production. Kaiser provided that organization. Once his methods were proven, other American yards adopted similar approaches. The result was production that scaled faster than German planners believed possible. By July 1943, the statistical comparison was stark. Germany operated approximately 430 U-boats. Each submarine required a crew of 48 men. Total U-boat personnel numbered approximately 20,000 sailors. The entire U-boat force, at maximum operational tempo, sank roughly 600,000 tons of shipping monthly. American shipyards. Building Liberty ships employed approximately 520,000 workers. These workers produced 900,000 to 1 million tons of new shipping monthly. One American shipyard worker contributed more to the outcome of the Atlantic War than one German U-boat crewman, despite the former never leaving California and the latter risking death in the North Atlantic. The Liberty ships themselves, crude and inelegant by traditional maritime standards, proved remarkably effective cargo carriers. Each ship could cross the Atlantic in approximately 12 to 14 days, depending on convoy speed and routing. A round trip, including port time for loading and unloading, required roughly 6 weeks. A Liberty ship could therefore complete 8 to 9 Atlantic crossings annually. With a cargo capacity of 10,800 tons, each Liberty ship moved approximately 90,000 tons of supplies annually. By mid-1943, over 800 Liberty ships were in service. That fleet was moving 72 million tons of cargo annually across the Atlantic, more than the entire British merchant fleet had moved in 1939. The military implications were profound. Operation Torch, the Allied invasion of North Africa in November 1942, had employed over 400 merchant ships to transport 107,000 troops and their equipment across the Atlantic. The operation succeeded because sufficient shipping existed to concentrate that much capacity in one campaign while maintaining supply lines to Britain and the Soviet Union simultaneously. Operation Husky, the invasion of Sicily in July 1943, required even more shipping. Over 2,000 Allied ships participated, including merchant vessels carrying troops, equipment, supplies, and fuel. The operation transported 160,000 Allied troops to Sicily, along with 600 tanks, 14,000 vehicles, and 1,800 artillery pieces. The logistics were staggering and would have been impossible without American ship production. General Dwight Eisenhower, commanding Allied forces in the Mediterranean, received regular briefings on shipping availability. His planning staff calculated that the invasion of France, tentatively scheduled for spring 1944, would require over 5,000 ships, including 2,000 merchant vessels dedicated to the operation. In early 1943, planners worried whether sufficient shipping would exist. By fall 1943, with American production exceeding 1 million tons monthly, the question changed from whether enough ships existed to which ships should be allocated to which operations. The surplus shipping capacity created by Liberty ship production enabled strategic flexibility that fundamentally altered Allied planning. When military planners debated whether to invade France through Normandy or southern France, or whether to expand operations in Italy, shipping availability was no longer the limiting factor. Sufficient vessels existed to support multiple major operations simultaneously. Admiral Ernest King, commander of the United States Fleet, noted in a planning conference in November 1943 that America was operating more merchant shipping than existed in the entire world's merchant fleets combined in 1939. The statement was statistically accurate. In 1939, total world merchant shipping tonnage was approximately 68 million tons. By November 1943, American-controlled merchant shipping exceeded 70 million tons and was growing monthly. The human cost of the Atlantic War remained severe despite Allied shipping dominance. Merchant mariners served aboard Liberty ships, knowing that U-boats still operated and torpedoes still killed. Between 1942 and 1945, approximately 200 Liberty ships were sunk by enemy action, representing 7.4% of total production. Those losses killed approximately 3,600 merchant mariners and Navy armed guard gunners. The death rate for merchant mariners serving in the Atlantic was approximately 4%, higher than any American military service except the Army Air Forces and Marine Corps. Merchant sailors received no military benefits, no veteran status, no recognition as combat participants. They were civilian contractors who happened to be sailing through war zones where people were actively trying to kill them. John Bunker, a merchant mariner who served aboard Liberty ships from 1943 through 1945, described the experience in oral histories recorded decades later. You knew the statistics. 1 ship in 14 was sunk. You knew that if your ship was torpedoed, your survival chances were perhaps 50-50, depending on water temperature and how quickly escorts could rescue you. You sailed anyway because the cargo needed to reach Britain. Soldiers needed ammunition. Civilians needed food. Your fear mattered less than the mission. The strategic impact of Liberty ship production extended beyond simply replacing sunk vessels. The ships enabled operations that would have been logistically impossible with limited shipping. The Soviet Union received massive quantities of supplies through the Lend-Lease program, much of it carried in Liberty ships, sailing Arctic convoys to Murmansk. These convoys faced German aircraft, submarines, and surface raiders in the worst weather conditions on Earth. The losses were severe, but the supplies kept flowing because sufficient ships existed to sustain operations despite losses. Between 1942 and 1945, Allied ships delivered approximately 18 million tons of supplies to the Soviet Union through all routes. Liberty ships carried approximately 40% of that total. The supplies included 7,000 tanks, 11,000 aircraft, 15 million pairs of boots, and 4 million tons of food. Soviet industrial production focused on tanks and artillery. American production provided the trucks, aircraft, and logistics supplies that allowed Soviet forces to maintain offensive operations. Marshal Georgy Zhukov, commanding Soviet forces in numerous critical battles, acknowledged after the war that American trucks and supplies were essential to Soviet victories. Without American trucks, the Red Army could not have conducted the rapid advances that characterized 1944 and 1945 operations. The trucks were delivered aboard Liberty ships that crossed the Atlantic and Arctic despite German efforts to stop them. The final accounting of Liberty ship production revealed the scale of industrial achievement. Between 1941 and 1945, 18 American shipyards built 2,710 Liberty ships. Kaiser's 7 yards constructed 1,490 ships, representing 55% of total production. The remaining 12 yards built 1,220 ships. Peak production occurred in 1943 when yards delivered 1,048 Liberty ships, an average of 3 ships launched daily. The construction time averaged 42 days per ship in 1943, falling from the initial 197 days required for the first vessel in 1941. The learning curve demonstrated what systematized production could achieve. Workers gained experience, processes improved, bottlenecks were eliminated, and construction time fell continuously. The cost efficiency matched the time improvements. The first Liberty ships cost approximately $2 million each. By 1943, costs had fallen to $1.5 million despite inflation and rising wages. The cost reduction reflected improved efficiency and economies of scale. Kaiser's yards were building ships assembly line fashion with costs approaching those of mass-produced manufactured goods rather than custom-built vessels. Total cargo delivered by Liberty ships during the war exceeded 270 million tons. That represented the equivalent of over 25,000 trainloads of supplies. If the cargo carried by Liberty ships had been loaded onto trucks and driven convoy style, the vehicle line would have circled the Earth's equator 4 times. The sheer volume of material moved by these ships was difficult to comprehend. The longevity of Liberty ships provided additional vindication of Kaiser's construction methods. Despite being designed as emergency vessels with expected 5-year service lives, many Liberty ships remained in commercial service for decades. The SS John W. Brown, built in 1942, remains operational as a museum ship in Baltimore as of 2024. 82 years after construction. The SS Jeremiah O'Brien, also built in 1942, participated in the 50th anniversary of D-Day in 1994, sailing to Normandy under its own power. Approximately 835 Liberty ships remained in commercial service through the 1960s, 20 years after the war's end. Many were sold to foreign shipping companies and operated into the 1970s. The last Liberty ship in commercial service, the SS Albert M. Bow, wasn't scrapped but converted into a fish cannery ship and remains today as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska. The post-war influence of Liberty ship construction methods extended far beyond maritime industry. The welding techniques, prefabrication approaches, and parallel assembly methods became standard practice in global shipbuilding. When Japan and South Korea rebuilt their maritime industries in the 1950s and 60s, they studied Kaiser's Liberty ship program and adopted his approaches. The massive shipbuilding facilities in Ulsan, South Korea, and Nagasaki, Japan, that dominated world shipping construction for decades, were direct descendants of Richmond Shipyard's revolutionary practices. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic impact in his post-war memoir published in 1960. We fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them. Japan's military planners assumed American industrial capacity was impressive but finite. They believed that if they sank enough ships, American logistics would collapse, and we would be forced to negotiate. They failed to account for American industry's ability to expand production beyond any limits they considered possible. By 1944, We were replacing losses faster than they could inflict them. Industrial capacity, not martial valor, determined the outcome. The German perspective on their Atlantic defeat was captured in Admiral Dönitz's memoirs, written during his imprisonment after the war. He acknowledged that Germany had fundamentally misunderstood American industrial capacity. German planners had calculated that destroying Allied merchant shipping faster than replacement production would force Britain to surrender. The calculation was mathematically sound, based on traditional shipbuilding assumptions. What Germany failed to anticipate was that America would revolutionize shipbuilding, eliminating the constraints that made the German calculation valid. Dönitz noted that if American yards had continued using traditional construction methods, Germany would have won the Atlantic War. British shipping losses would have exceeded replacement capacity, forcing starvation or surrender by late 1943. Kaiser's Liberty ships, crude and inelegant as they were, negated Germany's strategic advantage. The U-boat force was defeated not by superior tactics or technology, but by industrial capacity that exceeded German comprehension. The final irony was that Germany possessed the industrial base to match American ship production, but allocated resources differently. German shipyards built U-boats with meticulous craftsmanship, requiring skilled workers, and 9 to 12 months per submarine. Each U-boat cost approximately 3 million Reichsmarks and carried 48 crew. American shipyards built Liberty ships in 42 days, costing $1.5 million, carrying no crew but transporting 10,800 tons of cargo. Germany built 1,162 U-boats during the war, a remarkable achievement representing sustained, high-quality production. But that effort absorbed resources that could have built thousands of merchant ships, supporting expanded German commerce raiding or supplying German forces in occupied territories. Germany chose quality over quantity, craftsmanship over mass production. America chose the opposite and won. The story of Liberty ships ultimately demonstrates that wars are decided by logistical capacity as much as battlefield courage. German U-boat crews displayed remarkable courage, sailing submarines into waters patrolled by dozens of enemy warships equipped with radar and sonar. Thousands of German submariners died in the Atlantic. Their sacrifice achieved nothing strategically, because American industry simply built ships faster than U-boats could sink them. The mathematics were always inevitable once American production reached scale. German submarines averaged approximately 40 tons displacement. Liberty ships displaced 14,245 tons. The weight ratio was roughly 1 to 350. For every U-boat that survived long enough to sink one Liberty ship, which represented months of successful operations, Germany lost a submarine worth millions of Reichsmarks, 48 trained crew. America lost a ship that would be replaced in 6 weeks, and cargo that represented a small fraction of monthly production. Admiral King summarized the outcome in testimony before Congress in 1946. "We won the Atlantic War because we built ships faster than Germany could sink them. It was that simple. All the courage, all the tactics, all the technology mattered less than industrial production." Henry Kaiser's Liberty ships were not elegant. They were adequate. Adequate ships delivered in massive quantities defeated excellent submarines delivered in limited quantities. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.